solutions is diluting them from stock solutions. If you make a concentrated solution, you can, through diluting, taking a small volume of that solution and diluting it with your solvent, you can prepare new solutions, of course, with lower concentrations. And there's a very simple calculation for determining the volumes you need, and that is C1V1 equals C2V2, or sometimes written as M1V1 equals M2V2, if you're just using molarity as a concentration. But because these calculations work for any concentration, molarity percentage, parts per million, it's often written as C1V1 equals C2V2. So how does that equation work? Well, if you look at what a dilution is, we're going to take a small volume of a concentrated solution, say 150 milliliters, 0.15 liters of a 10 molar solution. We're going to then dilute it with our solvent, water, into a higher volume. Okay, so if you look at the equation, you'll see that the molarity, 10 molar, times the volume, 0.15 liter, gives you number of moles. And then doing the same with the diluted concentration, 0.5 molar, multiplying by the new volume, 3 liters, you get the same number of moles. Okay, and so if you know any of the three variables, you can calculate the fourth using this simple calculation. Okay, so here's an example of that. Say we want to prepare a 200 milliliter solution of 0.25 molar sodium chloride from a 2 molar stock solution. Okay, so what are we going to do? We're going to have our stock solution, 2.0 molar. Okay, we're going to take some volume out, and we're going to add enough water till it makes a 200 milliliter volume solution. Okay, so here we have, and we know that we want this to be a 0.25 molar concentration. So what we're looking for is we have C1, we know our volume of our final solution, we know our concentration of our new solution. We're looking for V1. How much of our stock solution do we need? Okay, so we can set this up as our C1 V1 equals C2 V2 calculation. We're solving for V1, so that's going to be C2 V2 divided by C1. V1, C2 is 0.25 molar. V2 is 200 milliliters. And we're going to divide that by our concentration of our stock solution, 2.0 molar. Okay, molarity is going to cancel out, and our V1 will equal 25 milliliters. So we need to take 25 milliliters of our stock solution and dilute it to 200 milliliters. We can also use molarity as a conversion factor for stoichiometric applications, and again, this is probably one of the biggest reasons why we came up with the concentration in molarity. Okay, if we want, we can calculate, we can go from volume to amount of moles of a given substance if we use molarity as a conversion factor. We can then use coefficients from a balanced chemical equation to go from moles of one substance to moles of another. And again, if we want the volume, we can calculate the volume of that substance if we know the molarity of that concentration. Okay, so let's do an example of that. Let's say we have a 0.15 molar KCl solution and react it with 0.175 molar lead nitrate solution. The lead nitrate solution has a volume of 0.150 liters. How much volume of KCl does I need to react completely with this? Okay, so what I'm going to do is go from volume of lead nitrate to moles of lead nitrate, moles of lead nitrate to moles of KCl, and then moles of KCl to volume using the conversion factor. Molarity is a conversion factor, that is. Okay, so I have 0.150 liters of lead nitrate if I had 1 liter of that solution, I know I would have, want to cancel out liters. Let's get rid of that. So, in 1 liter of that solution, I have 0.175 moles of lead nitrate. And our coefficients show us that 1 mole of lead nitrate will produce 2 moles of KNO3. So 1 mole of lead nitrate needs, not will produce, but will need 2 moles of KCl to react. And I know that I added a 0.15 molar solution, so 1 liter will have 0.150 moles of KCl. So my moles of KCl cancel, my moles of lead nitrate cancel, my liters canceled, and so when I throw this into my calculator, I know I'm going to have liters of my KCl solution for my final units, and throwing this in my calculator gives me an answer of 0.350